Hello, I am Shivadatta Gajala. I am a current master student from the Computer Science Department from the Seymour University, Southeast Missouri State University. So today I am going to explain about a project based on neural network and deep learning. My project is all about image and sound recognition. My advisor is Professor Dr. David Thai. So our project is all about uh, how we can utilize the machine learning concepts and deep learning things uh, and recognize the image and sounds. So before starting the things, we need to understand what is deep learning. Deep learning is a subfield of machine learning that deals with an artificial neural network, which are algorithms inspired by the structure and functions of brain. Deep learning is a class of machine learning algorithm that uses multiple layers to progressively extract high-level features from the raw input. For example, in machine learning, lower layers may identify edges while higher levels may identify the concepts relevant to the human, such as digits, letters, or faces. Most modern deep learning models based on artificial neural networks, specifically convolutional neural network, that is nothing but CNN, although they can also include proportional formulas or latest variable organizers. Layer-wise in deep generative models such as nodes in deep belief networks and sleep Boltzmann machines. In the industry, it is a daily problem classification of parts, fixtures, assembles, and goods of the part railway systems. So our project is can able to recognize what fruits and what vegetable are and what sounds are they are playing in the background. And audience for our project are automation of cars. Automation vehicles in image can detect and respond activities on roads. Many robots can assist the logistic industry in locating and moving the thing from one location to another. And in military surveillance, the detection of odd action in border areas or alien bodies, as well as automatic decision-making capabilities, can aid preventing inflation and save the troops' life. And we can also use in the medical purposes to recognize as a diseases before uh, getting advanced. In gaming industry, it can also be used for the developing of the character textures and etc. And the previous work have used a computer vision technology, which need a specific hardware like cameras, MRI scanners to scan the images, and it even needs a specialized team to monitor everything, and it does require a lot of monitoring continuously. Our our proposed system doesn't require a lot of monitoring, and it is more cost effective than the previous work that they had done, and it doesn't require that much time to train the models as well, because we were using ResNet, which is a pre-trained model, and the conventional neural network. The technical challenges that we faced during the developing of this project are the data processing. We have found an online source, which is nothing but a Kaggle, which provides an online GPU based on NVIDIA CUDA cores to train the models, and it does require time. It doesn't require much time as the previous work, but it requires a small amount of time to train the models, as we need to transfer the data from the local host to the servers, which are not in small number though. They are in a huge number, like around 90,000 images. So instead of using our local power GPUs and purchasing the GPU heavy load GPUs, we have used a Kaggle to process the data and everything. But we needed a stable internet connection so that we can transfer the data from localhost to the servers that are nothing but Kaggle. And the limitations, though we have tried our level best, we have a few limitations. We can't process the big size images, which are a huge number in pixels, and don't own the specific hardware, so we require high speed stable internet service to transfer the data. And till now we have our project can only able to recognize few images. And to recreate the our project, these are the technical information that are need to have to recreate the whole project again. So we have used a Python language and a tool called Kaggle GPU based from the NVIDIA CUDA courses, and we have implemented a deep learning technique called CNN, which is nothing but the convolutional neural network, and we also use the ResNet, which is a pre-trained model, and we have used a PyTorch, which is a machine learning library. To recreate our project, one need to have need to generate a username and a key with the Kaggle, and need to download dataset from the Kaggle. On the on the later part of the step, we need to import the modules and exploring the data, retrieving the training and test data sets. What is training sets? It is used to train the model that to compute to loss and adjust the weights of the model using gradients. And data transformation. Data transformation is nothing but randomized data augmentation will be applied randomly chosen transformation while loading images from the training dataset. Specifically, each image will be paired with 10 pixels, then flip the image horizontally with 50% probability. Final random rotation 20 degrees will be applied. And the data loaders. Now the data has been loaded and transformed into almost ready for training, but then we have to identify what is called data loaders. Usually while running the machine learning models, we will work with a large amount of data. Data will have to be processed by the computer, and computer have limited resources. It would be impossible to process the images or train the models without the images. We have included completely around 90,000 of images in our system to train the models. PyTorch comes with its model. We have a defined data sets. Using a GPU could help us to faster the process and train the machines more efficient and faster way. We have defined a custom CNN model to train our specific project, and we have reused a ResNet based on CNN model. After doing all this process, we have to move the data from one place to another. That is nothing but an implementation or deployment procedure. After that, when we give an input of an image of fruit or vegetables or anything, that our machine can able to detect what fruit or vegetable it is. In the conclusion, we have gained a convolutional neural network accuracy by 99.21% and ResNet accuracy by 92.45%. That is a great number actually. The deep learning neural networks are an example of an algorithm that natively supports multi-level classification problems. Neural network models of multi-level classification can easily define and evaluate the Keras deep learning library. Neural network models can configure to support multi-level classification and can perform well depending on the specific of classification of task. The two different conventional network architecture for image purpose were presented, and the rest model included in the PyTorch model. These are all the by doing this project, we have gained a lot of knowledge based on neural network, deep learning, ResNets, and we one can easily able to understand how a neural network and machine learning and the world of AI runs. Thank you.